All right, if you've been watching your videos, and unfortunately a lot of you have not been watching them consistently, really need to be watching these videos. But if you've been watching these videos religiously, we are at the last video, and I know that you're certainly glad for that. So this is section 8.1, part 2 video. We're solving quadratic equations by the square root property. I had worked one example right at the end of the section last time. We worked x squared minus 16 equals 0. In that particular example, I actually solved that problem by the factoring method first. And then we solved it by the square root property, and I showed you that we got the same answer. Well, if you can do one problem by both methods, why do we have both methods? Because there's not very many problems that you can solve, not very many quadratic equations that will solve by the factoring method and the square root property. Example, this one. So let's look at our second example, solved by the square root property, x squared minus 50 equals 0. See, if you take this problem right here and you try to solve this by factoring, it's got to be set to 0. It is. The problem is when you try to factor this is a binomial. Binomials will only factor as difference of two perfect squares or cubes. This is neither one of those. This is not the difference of two perfect squares because 50 is not a perfect square. So this problem right here could not be solved by the factoring method even if I wanted to use it. It won't solve it. So how do I know the square root property will work on this? First of all, because the instruction says solve by the square root property. But secondly, because this quadratic equation has two terms. One is your square term and one is your constant term. All right, so let's go through the steps. Step 1, isolate the squared term. That means get this by itself. It is not. So what I want to do is add 50 to both sides. And when I do, I get x squared equal 50. Now, if you come into this problem and you just pop a square root over all three of those, that whole problem is wrong. Because you don't take square roots first. That's step 2. Step 1 says isolate the squared term. So order in mathematics matters. Step 2, now take the square root of each side. So we do things to sides, not terms. So take the square root of both sides. Now, we learned last time when you take the square root of x squared, it just gets rid of that square. Secondly, don't forget the plus or minus. Always plus or minus. Now, can I get the square root of 50? No, I cannot. But I have to write it in reduced form. So, reduce it yourself or use your calculator. The perfect square that divides into 50 is 25. And square root of 25 is 5 square root of 2. I think the computer has a plus minus button, so you can enter it plus or minus 5 square root of 2. Or I think it will let you enter them separately by separating them by a comma. But if you do that, make sure that you do not put them in parentheses. Okay? Sorry. X squared minus 4 equals negative 85. Okay, here we go. Step 1, isolate the squared term. So I want to add 4 to both sides. When I do, I get x squared equal negative 81. Step 2, take the square root of both sides. When you do, this becomes x. This becomes plus or minus, always. I, because of the negative, under. And square root of 81 is 9. So that'll be plus or minus 9i. And again, you could enter it that way, I think, or you can certainly enter it this way on the computer. Okay? Let's do another one. Sorry. let's look at these two examples. Now, when you write these two examples down, when you first look at these, you say, oh, these are the same. No, they're not. They're close. So here we go. Step one. Isolate the squared term. Now, what's being squared right here? The square is above a parentheses. So the square is on the 3x. So I'm going to subtract 40 from both sides. And if you'll remember, I said in the last video, I said it doesn't have to just be an x squared. It can be some x stuff squared. All right, so there it is. Now, what is the squared term by itself? Yes, squared term, constant term. Step two, take the square root of each side. When you take the square root of this squared, it just leaves you 3x equals plus or minus just copy that down. I'll show you in just a second where that comes from. So just write it down for right now. Now, what are we solving for? Well, that square root got rid of that square. But you're not solved until the x is by itself. So I have to get rid of that coefficient, but whatever you do to one side, you have to do to the other. So this would be plus or minus 2I square root of 15 over 3. Now, you could write that 2I square root of 15 over 3, comma, negative 2I square root of 15 over 3. Another way to write it. Now, I said a while ago, where did this come from? I haven't shown you where this comes from. So let me show you that now. Square root of negative 60. Well, first of all, the negative, you know, is going to give you an I. 60, you cannot get the square root of, but it's divisible by a perfect square, which is 4. And then the square root of 4 is 2. Square root of 15I. Or 2I square root of 15. So that's where that comes from. Or use your calculator. Now, if you use your calculator, you can't punch the negative in there also, because the calculator is not going to give you the I. So you have to put the I in yourself and just punch in the square root of 60. Now, let's look at how this next one differs from the one I just worked. Okay, step one, isolate the squared term. So I want to subtract 40 from both sides. Now, here's what makes this one different. What makes this one different is, in this one, the square is not on the 3x. The square is on just the x. See, this 3x squared, let me come down here. This 3x squared is really this. It's 3 to the first times x to the second. Now, the reason that's different is, in this one, the square was above the parentheses. So all of it was your base. Here, the square is only above the x. So that 3 has to be dealt with first. So what I'm going to do is divide by 3 first. So see the difference in this one, you divide, then you square root. Over here, you had to square root and then divide. Saying it makes a difference on those two. Now take the square root of both sides. X equal, always plus or minus. Now 20, can't get the square root of 20, but 20 is 4 times 5, and square root of 4 is 2. Square root of 5, but you're going to have an I in your answer again because of that negative. 20 is 4 times 5, square root of 4 brings out a 2, leave the 5 under, and the I because of the negative. Okay? 2 more examples. Okay? Solve the quadratic equation. It has two terms, squared term, constant term. Yes, it's not just an x, but it's some x stuff squared. So it's a squared term and a number term. Step 1, get the squared term by itself. So add 25 to both sides. 0 plus 25 is 25. Step 2, take the square root of both sides. Now, what is that square root going to do to that square? It's going to get rid of it. Equals, always plus or minus. Now, this one's nice because the square root of 25 is perfect. It's 5. Now, you can't stop till you get the x by itself. So I've got to subtract 4 from both sides. When I do, let me first of all say what you can't do. You don't just say 5 minus 4 is 1 and put the plus or minus back in front of it. You have to write it this way. Negative 4, keep the plus or minus in front of that 5. Now, I do not want you to leave your answer this way. Here is why. Can you add negative 4 plus 5 together? Yes. Can you subtract negative 4 minus 5 together? Yes, you can. So don't leave your answer this way when both of these are just two numbers. So here's what I'm going to do. Your first answer would be negative 4 plus 5, which is what? 1. And the second answer would be negative 4 minus 5, which is negative 9. So anytime this is two numbers, don't stop right here. Go ahead and add them together and subtract them. Now, if this has an I with it or a radical with it, you can't add those together. But if this is a number and that's a number, you can add them together and subtract them together. And that's how you get those two answers. So let's do one more like that just to show you. Last example of the semester. Step 1, isolate the squared term. Subtract the 18 from both sides. Step 2, take the square root of both sides. So when you take the square root of this squared, it gets rid of the square, plus or minus. Now, I know there's going to be an I in the problem. And 18 is 9 times 2, and square root of 9 is 3. I, square root of 2. Now I've got to get the x by itself, so add 3 to both sides. And when I do, put the 3 in front of that plus minus. And that's your two answers. Now, I said this a while ago, but I'll say it again here. Now, you say, well, why don't you add these together like you do these? Because this won't add together. See, even if you broke this apart and wrote this way, you can't add those together because those are unlike terms. Remember, you can only add two terms together if their coefficients can be different, but everything behind their coefficients have to be the same. That's why I said if this term right here has an I or a radical or both, you will not be able to add those two together or subtract. Now you can enter them separately like this. You can enter them separately like that. But you can't add or subtract them. Now, let me say one other thing in closing on quadratic equations. So, we solve quadratic equations. Remember I told you at the beginning of the last video, I said that there's two methods to solving quadratic equations. One is the factoring method, and one is the square root property. All right, so let's look at this problem. You don't have to write this one down. This is a quadratic equation. we've covered two methods in here that solve quadratic equations. One is the factoring method in section 5.8. Step one, it has to be set to 0. Now factor this. This is a trinomial. It's the easy case. X and X, signs are the same, both plus. I need two numbers. When you multiply to get 5, you add to get 1. That's non-factorable. So you can't solve this quadratic equation by the factoring method. Well, then let's try the square root property. The square root property says you can solve it by using the square root property if it contains two terms only, your squared term and constant term. So the fact that this term right here is present means that you cannot solve this problem by the square root property. So here is a quadratic equation that can't be solved by factoring and can't be solved by the square root property. Does it still have two solutions? Yes. So there must be other methods out there that we haven't learned yet. And I told you on your first test in college algebra, one of the things that you do when you get into college algebra is you will look at the other two methods, because there's a total of 4, that teaches you how to solve quadratic equations. So we only cover 2 of those 4 in here. So this completely covers section 8.1 video, part 2. It also completely finishes this course. I hope you found these videos to be very helpful because as you know, as you've watched them, it takes an extreme amount of time to do these videos and then upload them to you, which is something I've enjoyed doing, but I hope that you have taken full advantage of the videos throughout this course. So this concludes this course. And so best of luck on your final exam.